Today we are going to be talking about simplifying radical expressions. So our radical expressions are our terms underneath a square root, right? So the first thing they have us writing down here is the product property of square roots. The product property of square roots says that the square root of any value, a times b, for example, is equivalent to the square root of a times the square root of b. So if it's written this way, it means the exact same thing as if it's written this way. Okay? Also the other way around. Maybe they gave it to you this way, but it's easier for you to solve the problem if it's written this way. You can write it either direction. Okay? So also true if read right to left. Okay, so next we're going to list out some of the most common perfect squares that we'll be coming across throughout the year when solving different problems. These would be some ones worth memorizing. Okay, so first one would be the square root of 1. What is the square root of 1? Good. Next would be square root of 4, which is good. Next would be square root of 9, which is good. Square root of 16. And square root of 25. Good. Okay. What about square root of 36? Square root of 49. Square root of 81. Oh, sorry, I skipped one, didn't I? I messed you up, sorry. 64. And then square root of 81. 9, yes. And then square root of 100. 10. Okay. Square root of 121. Good. 144. And 169. 13. Good. 196. Good. And 225. Good. Okay. So we do want to have our square roots through 15 memorized, just so that that's one less thing we're having to punch in our calculator. All right. Also, these are some common ones that are a little bit larger you might come across. Square root of 400. Good. Square root of 900. Good. Square root of 1600. Good. And square root of 2500. Good. So these are going to be the most common ones that we come across in problems this year. And if you know these common square roots or common radicals, then it's also going to help you with simplifying terms that don't have a perfect root. Because if we are looking for a perfect root, then we can use these to help us break it down. Okay, so let's look here at example 1. It says to simplify the square root of 180. So, as we just talked about up there at the top, I can rewrite some term underneath a radical as 2 numbers times itself, right? So I could have 18 and 10, right? Multiplies to give me 180. So I could write square root of 18 times 10, and that would still be equivalent to what I have written here, right? Okay, so whenever I am trying to simplify some radical, I need to try and take something out from underneath that square root. Obviously, there is no perfect square root of 180, right? We can't just type it in our calculator. If we do, it gives us a decimal. So we just want to simplify it as much as we possibly can. If you don't know your multiplication tables, or you don't know these up here, then you're not going to know what's best to help you simplify. You might have to take the long way to get there. Okay? Does anybody know of a set of numbers that multiplies to give me 180, and one of those numbers does have a square root?
36 and 5.
Very good. So I can rewrite this as the square root of 36 times 5. And according to our product property from up there at the top, I could also write this as square root of 36 times square root of 5, right? Those mean the same thing. Okay? And what is the square root of 36? Very good. But is there a square root of 5? No. So that just stays underneath the radical. Okay? All right, in this same little space here, let's try another one. Let's look at the square root of 363. So I am trying to think of a number that will multiply to give me 363 that will have a square root, the biggest one we can come up with.
11 and 33.
Well, 11 and 33 do multiply to give me it, but
121.
that neither one of those numbers has a square root, right? What'd you say?
121 and 3.
There we go. 121 is the number I'm looking for. Its square root is 11, which I think is what he was going for there. So 121 times 3. Like we said here, I could rewrite those as two separate radicals being multiplied together. And I think this is what you were going with. The square root of 121 is the 11, right? So I could rewrite this as 11 square root of 3. Okay? Now let's do one more. Let's do square root of 75. So what will multiply to give me 75? Very good. And we can rewrite this as two separate radicals being multiplied together. And this would simplify to what? Very good. 5 square root of 3. Nice. Okay. All right. So example 2, it's different, right? It's already split into two different terms. They're wanting us to simplify, so we're going to need to multiply these two terms together. Okay. So whenever we are multiplying terms like this, it's just like if it were, if your radical were a variable. You can multiply the terms out in front by each other, and you can multiply the radicals by each other. Okay. Just like if it was 2x times 4x. I would multiply the 2 and the 4, and I'd multiply the x and the x, right? So here, when I multiply, I'm going to be multiplying the 2 and the 4, because those are kind of like like terms. So I would have 2 times 4 that I can multiply, times my numbers that are under the radical. I can multiply those together. So square root of 10 times 5. So if I actually multiply those terms together, what does this become? 8. Square root of what? Very good. Okay, so not too bad. Now once we're to this point, we want to use our tricks from over here to see if we can simplify this term any further. So can you guys think of something that will multiply to give me 50? 25 and 2. So I would have 8 times the square root of 25 times 2. And remember, we can split those up. So square root of 25 times square root of 2. Okay? And what is the square root of 25? 5. So there's there's already an 8 out here. We're taking a 5 out. So now I'm going to have to multiply those terms together. We still have that square root of 2. So remember, when two things are beside each other, that means multiplication, right? So all along, this has been multiplication. So when I take it out of the radical, I am going to have to multiply it. So we're going to end up with
40.
So I have 40 square root of 2. Okay? All right. We have one more property that we want to talk about with a few more examples. So at the top, we talked about product property. Here we're talking about quotient property. All right? So product means to multiply. Quotient means to... Good. So this property says that the square root of any two terms being divided, A divided by B, is equivalent to the square root of A over the square root of B. Again, this is also true going this direction back to this. You can go either way, whatever is easier in your problem. Okay, so keeping this property in mind, let's look at example 1. Okay, so currently we have square root of 9 divided by square root of 3. According to this property, it's written this way. I could rewrite it this way and it would still mean the same thing, right? So I'm going to go ahead and do that. Okay, so can I simplify what I have under this radical here? Yes, what is 9 divided by 3?
3.
And then we didn't have to break anything down. We didn't really have to take any square roots. We just simplified what's underneath there, right? So this is an example of it was easier for us to simplify when written this way, right? Okay, let's come over here to this example. Okay, so again, these are terms under the radical, so that means we can multiply them together since they're both underneath the radical. So this would mean that I have 3 times 5 over 4 times 2 underneath my radical. So we would want to go ahead and multiply those terms. So this is going to become square root of what? Very good. Okay. Now, is 15 divisible by 8? No. So it's not really helpful for us right now to be written this way. So what we're going to do is rewrite it this way and see if we can simplify anything. Okay? So we would rewrite this as the square root of 15 over the square root of 8. Okay. So 15, we know it doesn't have a square root. Is there anything that multiplies to give you 15 that has a square root?
3, 5.
So 3 times 5 does give me 15, but does 3 or 5 have a square root? So it doesn't look like the top is going to simplify. Okay, I'm going to have to leave it as square root of 15. What about in the bottom? Is there anything that multiplies to give you 8 that has a square root? There we go. So I could rewrite this as square root of 4 times square root of 2. Right? And what is the square root of 4?
2.
Good. So this would become square root of 15 over 2 square root of 2. Okay? And we will be dealing with radicals a lot in lessons to come. And we actually don't typically ever want to leave a radical here in the bottom of a fraction. We're not going to talk about how to get rid of that today. We'll talk about that later on. But that's what's called rationalizing the denominator. So we will learn to rationalize the the denominator later. Alright. This